Hi students, welcome to physics classes. In previous classes, in the chapter Electromagnetism, we discussed about Oersted experiment. In that, we have seen current carrying conductor is producing magnetic field. From the experiment done by Oersted, we have seen that current carrying conductor produces magnetic field. Then after we discussed magnetic flux density. Now we will discuss magnetic field due to, we know current carrying wire produces magnetic field. That how it is when a wire is straight. Magnetic field due to straight wire carrying current. Magnetic field, how it will be. Now to do that experiment, we need a plank. This is a plank which is placed on the table. Actually here table, on the table we are placing the plank. This is the table, on that we placed a plank, and the plank is having a hole. Plank is having a hole, and we need a stand. This is the stand. For this stand, with the help of this stand, we have taken 24 gauge copper wire, and it is passing through the hole of the plank. To make it straightly, we can keep a weight here. Then wire will be straight. And this is connected to a battery, which is, we can take either 3 volts or 9 volts, and a switch to be connected. And through the whole wire is passed, no? Around that wire, around that hole, we are placing magnetic compass needles. 6 to 10 we can place. 6 to 10 we can place. Now, this is a circuit. Once again I will repeat. Now we have taken a table. This is the table. On the table a plank is placed. On the plank we placed the stand. We have taken the 24 gauge copper wire. Means in our houses copper wire we are using, that is 24 gauge. Now that wire is passed along the hole, through the hole of the plank, and it is to be straightly, because we are doing straight wire, magnetic field due to straight wire carrying current, and a battery is connected. To make it straightly, we placed some weight here, and a switch is connected. Switch is on generally. Now around that wire we placed magnetic compass, 6 to 10 compass needles. Here I have taken 6 diagrams based on the size we can take. Now whenever switch is on, current is passing along the wire. Current is passing along the wire, electric wire. Current is carrying wire. Now when the current is passing, this already we know, when current carrying wire, magnetic compass needle placed near the current carrying wire, it is deflecting. So these are deflected, and north south it is pointing in a direction. Needle is pointing in a direction. If you keep the points along both ends of the compass like this, keep the points along the both ends of the compass. When the current is flowing, if current is not there, compass needle generally shows north south direction of the earth. When we switch on, current is flowing, then it is deflected. That electric current influences the magnetic compasses. Then magnetic field is generated. Due to that magnetic field produced by the wire, magnetic compass needles gets deflected, and the points shows in a particular direction. And if you keep points head and tail of the magnet compass head, the tail of the compass, head, the tail of the compass for all the compass needles, and remove entire arrangement. If you join, you will get a circular path. You will get a circular path. At any point, you will get a circular path. Circular path. If you join that all the points, you will get a circular path. So by this we can say magnetic field lines. These are the magnetic field lines are closed. Magnetic field lines are closed. Now what is the direction of a magnetic field line? At any point, if you take here, if you find here, if you draw the tangent on this point, you can find the magnetic field lines direction. Magnetic field lines direction. If you keep it still more far, you will get like this. You will get like this. Still more far, you will get like this. Magnetic field lines. They never intersects. They never intersects. Now this is the magnetic field lines. Magnetic field lines. Now by showing that arrow mark, magnetic compass needle arrow mark, we can keep the arrows here. We can keep arrows here. Here, based on main important question they are asking in the exam. Important question they are asking in the exam. They'll give you magnetic field direction. Either clockwise or anti-clockwise. Magnetic field direction, and they are asking what is the direction of current. What is the direction of current? Now to find the direction of current when they given magnetic field direction like this, here we are getting circular shape. So like this we are getting. Now they will keep arrow mark to show the direction of magnetic field lines. To show the direction of magnetic field lines. Now how to find the direction of current? How to find the direction of current? So we should use right hand thumb rule. Right hand thumb rule like this. Now we should fold the fingers, curl the fingers like this, and point the thumb upward direction. Curl the fingers and point the thumb upward direction. Now these curled fingers indicates the direction of magnetic field. Curled fingers indicates the direction of magnetic field like this. Curled fingers indicates the direction of magnetic field, and thumb indicates the direction of current. Thumb indicates the direction of current. Now see for first diagram like this. Anti-clockwise direction. I am folding the fingers. This arrow mark fingers direction, both are same. So current pointing out of the page. Current pointing out of the page. Current is pointing out of the page. Dot. When current is pointing out, we can denote with the dot. Now second figure. Now current is flowing in clockwise direction. Sorry, magnetic field in a clockwise direction. Magnetic field in a clockwise direction. So see, clockwise direction. Clockwise direction. Fingers go clockwise direction. Whenever I kept like this, clockwise direction. This fingers direction, clockwise direction. Now whenever it is showing clockwise direction, thumb is pointing downward direction. Thumb is pointing downward, so into the page. Current is flowing into the page. Into the page with the cross mark you should denote. Into. This one we say into. Cross we can say into. In regular words, cross we can say into. So into indicates into the page. We can remember easily. Easily we can remember. Into denotes into the page. Dot denotes out of the page. Dot denotes out of the page. Like this we can find the direction of current. Whenever they given magnetic field, we can find the direction of current. Here also we'll get. Now for example, Now if I kept like this arrow marks for this, now we should place right hand thumb rule like this direction, fingers folding like this. Now into the page, into clockwise into the page. Now if you draw like this, we should place, like this we should place. Thumb indicates out of the page, dot out of the page. These are very 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 important. Number of times they are asking in the exam. Magnetic field due to straight wire carrying current. So by joining this we are getting like this. So we can conclude that straight wire producing magnetic field in a circular path, circular direction. Magnetic field lines are circular direction. Whenever we see bar magnet, we are seeing magnetic field line is traveling from north pole to the south pole. This side also north pole to the south pole. Now here magnetic field starting from the north pole and ending at the south pole. So here we are unable to conclude. Even we discussed it is going south to north inside of the magnet, but to more clearly we can understand here. So by this experiment we can say magnetic field lines are closed. Very very important. Magnetic field lines are closed. They never intersect. They'll start from north pole, ends at south pole out of the magnet, and inside the magnet south pole to the north pole. Inside the magnet from south pole to the north pole.